Hello, everyone. Thank you for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. For today's session, we'll be doing the Oracle Cloud Networking Quick Start, where we will cover some core OCI networking services, how to deploy them, and best practice considerations for when and why to use these services. Now, I'd like to introduce Brandon and Olivia as our main presenters.
Awesome. Thank you, Borna. Hi, everyone. My name is Brandon O'Leary. I'm a cloud engineer here at Oracle. I'm part of the customer enablement team. And we also have Olivia joining us today. Olivia, do you want to introduce yourself before we jump in?
Hi everyone, I'm Olivia Ferda. I'm also a cloud engineer on the customer enablement team, and I look forward to today's networking quick start.
Awesome.
Awesome. And with that, I'll hand over to Brandon.
All right. Thank you, Borna. So for today's session, we are going to focus on OCI's networking services. There's quite a few different services relating to networking. Looking at the agenda, first we'll start off talking about virtual cloud networks or VCNs. Then we'll take a look at subnets, route tables, the different gateways that are available within OCI's networking service. We'll take a look at peering different virtual cloud networks together. That's going to be the process of connecting different virtual cloud networks so that their resources can communicate using private IP addresses. Then I'm going to hand it over to Olivia, who's going to take us through VCN security. So by default, you have your built-in firewall rules, and those are going to be your security lists and your network security groups. And then load balancing. So how can you distribute traffic among multiple servers within your backend set. So load balancers will help automate traffic distribution. And then we also will talk about some different connectivity options. So how will you connect over into your virtual cloud network that's running within Oracle Cloud? Will you use a VPN? Will you use FastConnect, which is like our dedicated virtual circuit option? So there's different connectivity options we'll take a look at as well. We'll also have some demonstrations built in throughout this training. So I'll do a demonstration about halfway through. I'll show you how to create a virtual cloud network within Oracle Cloud. And then at the end, Olivia will take us through the network visualizer. And then also, if we have time, we'll take a look at the load balancing service as well. So by the end of this presentation, you'll be able to understand the core networking services within OCI. You'll be able to explain virtual cloud networks and subnets. You'll also be able to compare different networking gateways and their use cases. You'll be able to provision and deploy different networking resources within your tenancy. All right, so we have our introduction to networking within OCI. Before we jump into networking in particular, we like to show this slide at the beginning of many of our sessions. And this essentially shows that Oracle Cloud has a complete cloud ecosystem with many different tools and services that are available for your most complex use cases and even the simple ones too. So if we take a look here at this diagram, right, this has many different service domains, and our core services are going to fall under compute, storage, and networking. But within each one of these domains falls, a wide range of different services. So when we drill into networking, we're going to take a look at many of the networking services such as virtual cloud networks, the components that are going to be tied into your virtual cloud network, such as the route tables, the different gateways, security lists. This essentially outlines that there is much, much more to Oracle Cloud than you can really fit into one session. So just at a high level, we do have developer services available, different services that can help you build out like CI/CD pipelines. We have a resource manager service as well that can help you manage Terraform deployments, and then containers and functions. So if you are familiar with running like microservices applications, you can leverage containers. We also have functions. So that's essentially like serverless computing. So you're only paying for the execution time of your code, but you don't have to worry about managing any underlying infrastructure. Application integration. So if you want to integrate different sources of data, different applications, you can facilitate different types of integrations using Oracle Integration Cloud. That's going to be one of our PaaS services. We also have some analytics tools as well, and Oracle Analytics Cloud would be one of those. Machine learning and AI capabilities, Oracle database. So there's many different ways to deploy Oracle database on the cloud. You can deploy it on a virtual machine. You can get, dedicated Exadata infrastructure. You can also run Oracle database on autonomous database. So essentially with autonomous, that's going to be, fully managed. All of the database lifecycle activities would be fully managed by Oracle. And we really automate many of like the mundane administrative tasks that you would typically see with a more customer managed database deployment. There's also open source databases as well. So like MySQL is one of them that's available within the cloud. But we will focus strictly on networking throughout this presentation. All right, so setting up your network within OCI, you have your virtual cloud network or VCN. The VCN is going to be your customizable private cloud within OCI. So it's similar to a traditional data center network, but it's going to be within the cloud. And the virtual cloud network is going to provide you with complete control over your cloud networking environment. There's also built-in visualization tools that will help you to troubleshoot connections or any connectivity issues. The subnet, so you'll break up your VCN into subnets. So these are subdivisions of the VCN, and they act as individual units of configuration. So you can have private subnets, you can have public subnets, you can have regional subnets, AD specific subnets. So we'll dive deeper into subnets as well. Gateways. So with gateways, you know, there's different gateways for different purposes. We have an internet gateway, we have a service gateway, dynamic routing gateway, NAT gateway. We're going to go through each one of these different gateways and discuss what their purpose is and what their use is. Load balancing. So the load balancers are going to provide automated traffic distribution from one entry point to multiple servers that are going to be reachable from your virtual cloud network. Load balancers will improve resource utilization. They will help to facilitate scaling, so you can, tie them into auto scaling policies. And then also they will help ensure high availability, right? Because you can distribute your nodes on the backend set. And also by default, the service is going to be highly available as well. So it's going to be redundant at the LB level, so at the service level. DNS, so within our, broad offering of networking services, we do have a DNS service, and there's public and private DNS within Oracle Cloud. So with public DNS, it provides high availability and global traffic shaping for your applications, no matter where they run. And this will help to ensure high optimal website and web application performance. And then we also have private DNS. So with private DNS, you can create private DNS zones in your VCN. And then you can also interconnect DNS between your on-prem and your cloud networks. FastConnect, this is one of our connectivity options. This essentially allows you to connect directly to your OCI virtual cloud networks with a dedicated private line. It's going to be, a high bandwidth connection, dedicated virtual circuit. It's going to provide a predetermined path for data movement, avoiding collisions, packet ordering, and then any security and latency issues that are going to be inherent with data transfer over the public internet. All right, so taking a deeper look at the virtual cloud network or VCN. On the left-hand side here, we have an architecture diagram. So this kind of shows you how that would look when you deploy a VCN within a region. So here you can see we have our region. That's going to be this outermost box. And then within that region, we have different data centers, or they're referred to as availability domains or ADs. And sometimes, typically there'll be three different availability domains within a region. So just keep that in mind, although this graphic here only shows one availability domain. And the VCN is going to be regional in the sense that it spans all of the availability domains within a region. So you can see here that we have one AD, but if there was multiple, like in this next slide here, you can see, it's a regional construct in the sense that it's going to span all of the availability domains within a region.
And Brandon, is there a best practice or recommendation on using an 80 specific subnet or a regional one?
Yeah, good question. So, next up we have subnets, right? And subnets are going to be how you subdivide your networks further. And like Olivia mentioned, like there are regional subnets and availability domain specific subnets. So you can see here we have subnet D, and this is an example of a regional subnet. So it spans across all of the data centers within a region. So it's similar to the VCN in the sense that it spans all of the availability domains. And why you would use this is because it's useful for high availability. So it would actually be like recommended to use a regional subnet for high availability because it does span across multiple availability domains. Yeah, on top of that, so subnets can be regional or AD specific, and then they can also be public or private. So with a public subnet, when you deploy, a host or instance within a public subnet, that's going to give the host both private and public IP addresses. And then with a private subnet, that's going to prohibit public IPs from being assigned. So your instances are going to only contain private IP addresses assigned to their VNICs within the private subnet. All right, so we can take a deeper look at the VCN address space. So a VCN is going to cover one or more IPv4 CIDR blocks of your choice, and the sizes are going to range from a /16 to a /30. So in this diagram here, or topology, we are showing a /16. So a /16 is going to be the largest, and that's going to give us around 65,000 IP addresses. From there, we're taking this, 10.0/16, and we're breaking that up into subnets. So we have the 10.0.1.0/24. This is essentially, we're taking this big chunk and we're breaking it up into smaller chunks. So we have two subnets, right? And then the /24, that's going to give us less usable IP addresses. That's going to give us around 256 usable IPs. So depending on the amount of hosts or databases or public IPs that you would need within your subnet is essentially how you would size out these subnets. And if you're unfamiliar with this concept, we do use CIDR. Classless interdomain routing is what that stands for. And essentially, that's a range of IP addresses that the network is going to use. the CIDR address is going to look like a normal IP address, except that it ends with a slash followed by a number. And the number after the slash is going to represent the number of addresses within that range. Right, so I kind of explained that at a high level, right? With the 16, that's going to give us the largest amount of IPs. And then we're breaking that up into smaller chunks with the slash 24. All right, and next up we have our route tables. So your virtual cloud network is going to use route tables to send traffic out of the virtual cloud network. So as an example, to the internet, to your on-premise network, or even to a peered virtual cloud network. These route tables have rules that look and act like traditional network routing rules that you may already be familiar with. Each rule is going to specify a destination CIDR block and then the target, which is the next hop for any traffic that matches that CIDR. Traffic within your virtual cloud network subnets are going to be automatically handled by VCN local routing, and no route rules are required to enable that traffic to flow. If there's no route rules that matches the network traffic you intend to route out of the VCN, the traffic would be dropped. Another important thing is that the route that's more specific is going to get priority. So it doesn't necessarily matter about the order. It just, it's the route that's more specific is going to take priority. So here we have an example of a route table. And this is tied to one of our private subnets. This is a screenshot directly from the OCI console. And if we take a look here, you can see we have our destination, our target type, our target, and then a description. So if we take a look at the second route rule, essentially it's saying that all traffic that is destined for object storage is going to be sent through our service gateway. The other route is saying that all other traffic is going to be sent through the NAT gateway. So essentially, it's governing how a subnet's traffic is leaving the VCN, leaving the subnet where it's going to be sent. And we're going to get into these gateways here in the next couple slides, but there's a good reason why you'd want to set up the route this way, and a good reason why you would want to leverage the service gateway. All right, so let's get into the different gateways. First up, we have communication to the internet. We have what's called an internet gateway. The internet gateway is going to provide a path for network traffic between your virtual cloud network and the internet. Next up, we have our NAT gateway. The NAT gateway is going to enable outbound connections to the internet, but it's going to block inbound connections initiated from the internet. So some main use cases are going to be for downloading updates and patches from the internet. A little bit more information about how the NAT gateway is going to work is that when a host within the private network here initiates an internet-bound connection, right? So we have our private subnet. The NAT device's public IP address is going to become the source IP address for that outbound traffic. So if we have like a database or a compute resource in our private subnet running, we try to download, an update or a patch from the internet. The NAT device's public IP address is going to become the source IP for the outbound traffic. And then the response traffic from the internet is going to use that public IP as the destination IP. And then from there, the NAT gateway is going to route the response to the appropriate host within the private network that initiated that connection. All right, so in addition to the internet gateway and the NAT gateway, we have what's called a dynamic routing gateway, or DRG. And the DRG is going to provide a path for private traffic between your VCN and destinations other than the internet. So you'll use it to essentially sit in the cloud, connect to your VCN, and act as a virtual router, which will essentially provide a path for traffic between different sources and your VCN. And it can be between your on-prem network, other other virtual cloud networks within OCI, within the same region, other virtual cloud networks within OCI in a different region, and then also other networks and third-party cloud providers. All right, and then last up for gateways, we also have a service gateway. So with the service gateway, this is going to let resources in your virtual cloud network access public OCI services such as object storage, but without using an internet or NAT gateway. And any traffic from the virtual cloud network that's destined for one of the supported public services is going to use the instance's private IP for routing, and the traffic is going to travel over OCI's network fabric and stay on OCI's backbone. It's never going to traverse over the public internet. So a good use case here is going to be for sending backups of your databases over into object storage, right? You don't want those backups to traverse over the public internet. So you can send those backups specifically through the service gateway. Another important thing to know, like when you're working with gateways in general, so anytime you add a gateway to your network, you'll have to go into one of the subnet's route tables and add a route for traffic to be able to flow through that gateway. So if I added a service gateway, I would need to go into the private subnets route table down here, add the route rule for traffic that's destined for object storage to be sent through the service gateway. And then we have an example of what that looks like here. So switching back over into the route table, we have that example right here. All right, so the last thing that I'll discuss before jumping into the OCI console and doing a demonstration for everyone is peering. So peering, this is the process of connecting multiple VCNs together. We have local VCN peering. This is going to be the process of connecting two virtual cloud networks, two VCNs within the same region, so that the resources can communicate using private IP addresses. And then we also have remote VCN peering. So with remote VCN peering, this is the process of connecting two VCNs in different regions so that the resources can communicate using private IPs. So with local peering, you can leverage a DRG, and essentially you would go in, create a DRG, connect that or attach that to each VCN, and then you can set up routing rules to send traffic through the DRG if it's destined for the address range of the corresponding virtual cloud network that you're trying to attach it to. We also have the option of local peering using an LPG or local peering gateway. So this is another option that's available through the console. And with that, it's pretty simple. You would just spin up a local peering gateway on both VCN. So one on VCN 1 and then another on VCN 2. And then from there, you can essentially go through like a couple of clicks and then you can peer those gateways together. And that would also enable traffic and achieve the same result. And then we have remote VCN peering. So with remote VCN peering, we would just have two DRGs. So one DRG in region 2 and then one DRG in region 1. but the process would look very similar. So you would still have to set up routes within like the route table that essentially says, traffic destined for this range of IPs. That would be the other VCN CIDR block. If traffic's destined for that VCN, then it's going to be sent through that particular gateway. All right. So we are about halfway through the presentation. I'm going to jump in and show you all how to deploy a virtual cloud network. All right. So you should all be able to see the OCI console. So when you get logged in, this is going to be the home page that you're greeted with. So this is going to be like the main landing page. If we come over to the navigation menu at the top left and expand on that menu, we have a whole section here on networking. And within networking, this is where all of the things that we talk about today are going to be located. So we have VCNs, load balancers, DNS service, customer connectivity option. So you have your VPN, FastConnect, your dynamic routing gateway, IP management. So you have the option to bring your own IPs, network command center. So we'll also take a look at the network visualizer, but there's some other tools there as well. But first up, we'll take a look at virtual cloud networks or VCNs. So I'll click on that. All right, so here you can see I already have some different networks created, and it's really simple to create a virtual cloud network. So they give you a couple options here. You have a manual option, so you can create the virtual cloud network. You'll click create a VCN, give it a name, choose a compartment that you want to create the network in. So the compartment, this essentially is a logical container for your resources. So you can see here, these are all of the different compartments. So where do I want to create this network within this particular compartment? And then next up, you'll give it an IPv4 CIDR block. All right, so from there, we'll scroll down. So you have the option to use IPv6. So if you want to use IPv6 prefix, you can add one of those now. But you can also enable this and add IPv6 later on an existing IPv4 only VCN. So with that being said, you just click create VCN, and then after a couple of moments, you'll see the virtual cloud network is created, and then you can begin building out more networking resources, and then you can begin, placing instances and databases within this network. So next step, you would create your subnets. So I can show you how to do that here as well. Click create subnet, give it a name, subnet type, so regional or AD specific. So you can see regional is recommended because it is useful for high availability. It's going to span across all of the ADs within a region. Next up, you'll give it an IPv4 CIDR block. Choose if you want it to be private or public. And then, your security list. So select your security list and then just click create. So now we have a subnet, and then I can begin to place different resources within this subnet and begin to build out my workload within this network. All right, so I showed you how to create a VCN manually and then also how to add a subnet. I'll show you the wizard option as well. But first, let's go ahead and delete this first subnet that we created. So when you click that red delete button, it's going to pull up this next page, and you can scan all of the different compartments within your account. 4 different resources associated with this VCN. But if you know what compartments everything's in, you can just select those specific compartments and then click scan. From there, it's going to show up with a list of all the associated resources. So you can see here, it's just the one subnet that I created. And then we'll go ahead and click delete. And then you can see that virtual cloud network is completely gone and deleted. All right, so the other option when we are working with virtual cloud networks through the UI is going to be to leverage the VCN wizard. So if you click on this, there's 2 different options here. You can create a VCN with internet connectivity, or you can create a VCN with internet connectivity and then also configure a site-to-site VPN to your on-prem network. So the main difference here is with the wizard versus like the manual process. The manual creation process of a VCN is just going to give you the VCN, but it's nice with the wizard because this will automate the creation of many associated resources that we commonly see created and used with virtual cloud networks. So it's going to create these different gateways. So the first option, it's going to create an internet gateway, a NAT gateway, and a service gateway. It's also going to create 2 different subnets, one public, one private, 2 different routing tables, 2 different sets of security lists. So we'll go with this first option. Give it a name, compartment, configure your VCN IPv4 CIDR block. So it's going to be 10.0 by default. But you can change this. And one important thing to know is that if you plan to peer this VCN with another VCN, you want to make sure that those VCNs do not have overlapping CIDR blocks. Next up, you'll configure the public subnet and private subnet. You'll enter the CIDR blocks for the public and private subnet, and then you'll just click next. It's going to go through a review page to review all the resources that are going to be created. So here you can see we have our subnets, our VCN, virtual cloud network, our gateways, our security lists, our route tables. So we went over the route tables in quite a bit of detail, but the security lists, these are essentially going to be your firewall rules. So by default, when we go with the wizard option, that's going to give us some default firewall rules within our security list. But you can go back in and you can change and modify the ingress and egress rules on your security lists. So that's a good segue into our next portion. I'm going to hand it over to Olivia, who's actually going to take us through security lists.
Brandon mentioned we're going to be diving into more VCN security, and then we'll also be covering a few other services like the load balancing service. So once you have your VCN, your subnets and everything set up, you have your instances in those subnets. Let's say you want to automate the process of distributing that traffic. You can do so with your load balancer. And then we'll also explore some of the different connectivity options. All right, so going into VCN security, where I really want to focus right now are security lists. So a security list is going to act as a virtual firewall for an instance that has rules associated with a subnet and applied to all VNICs launched inside that subnet. And a VNIC or a virtual network interface card enables an instance to connect to a VCN and also determines how the instance connects with endpoints inside and outside of that VCN. And that security list consists of rules that specify the types of traffic allowed in and out of the subnet. So you can kind of see an example right here for your security rules. And they can be stateful or stateless, and the default is going to be stateful for your security rules. But you can change that if needed. And stateful just indicates that you want to use connection tracking for any traffic that matches that rule. So when an instance receives traffic matching the stateful ingress rule, that response is tracked and automatically allowed back to the originating host, regardless of any egress rules. And when an instance sends traffic that matches a stateful egress rule, the incoming response is automatically allowed, regardless of any ingress rules. So that's more stateful, that's the default. If you want to change it, you can also do stateless. And that just indicates that you do not want to use connection tracking for any traffic that matches that rule. So this means that response traffic is not automatically allowed. So in order to allow the response traffic for a stateless ingress rule, you must create a corresponding stateless egress rule. And a common practice is to use stateless rules for more high performance applications. And in any case where network traffic matches both stateful and stateless security lists, that stateless rule is going to take precedence there. And just to dive a little bit deeper into the two different firewall options that you have available within OCI. So we kind of already covered security list in the previous slide, and this depicts more of the image on the left-hand slide. So this lets you define a set of security rules that applies to all VNICs in entire subnet. So all of these rules right here applies to all the VNICs in the subnet tier. Whereas you also have something called a network security group or NSG, and this lets you define a set of security rules that applies to a group of VNICs of your choice. So it lets you be a little bit more granular in terms of security and can be used, also with your security list. And one example is, let's say for the servers in the subnet right here, you want to allow both servers to permit SSH on, let's say, port TCP/22. But you also only want one of these servers to allow ICMP or something like that. So you can use a security list to permit SSH on port TCP/22. But if you want to get more granular, you would include the VNIC for only allowing server A to allow ICMP. So once again, those NSGs will give you the ability to create a more granular security. All right, so that was a little bit more on VCN security. Now I want to switch gears and dive into the load balancer service. So once again, this is just going to provide an automated traffic distribution from one entry point into multiple backend servers into your VCN. And this helps to load balance large amounts of traffic, which could overwhelm a single server. It also allows for scalability by allowing a mechanism to scale out an application tier by adding more servers. And you're also going to have application high availability. So even if, let's say, one availability domain has an issue, you can still be up and running in other availability domains. And it has several different features, and if we have time, we might see this in the demo, but you have a health check. So if one of your backend servers is down, you'll see that it might have a critical health or something like that. So you'll see the shift there.
Olivia, are there different distribution methods that can be used with the load balancing service?
Yeah, so that actually brings us to the algorithms right here, and you have three different types to choose from. So by default, it's going to be round robin, and this would distribute traffic sequentially. So go server A, B, C, D, and then repeat that process. But you can change that if you want to be IP hash, which would use the IP address and route to the same backend server. You also have least connections, which would distribute traffic to the server with the fewest active connections. So you can change those different algorithms for routing that traffic.
Nice.
And then diving a little bit deeper into how the load balancer service works. So there's two kinds of load balancers. You have a public load balancer and a private load balancer. So let's first dive into how the public load balancer works. So for this, you select two availability domains or AD where the load balancer resides in. So we have AD1 and AD2 right here. So since OCI creates two copies of the load balancer to make it highly available, you need two subnets. And then after creation, the public load balancer sits at the edge of a VCN. And there's a primary load balancer selected automatically to hold that public IP. And then a secondary load balancer in an active standby configuration. And then next you have a listener right here, which is the public IP address and the service ports that are opened up to sit between the internet and your backend server. So if one of the ADs goes down, that listener will fail over to the other available domain automatically. And where we see this dotted line right here at the top will be the new path for that traffic. And this high availability is built in and not managed by the user. So that's kind of the public load balancer setup. The second type of load balancer is a private load balancer, and the implementation is a bit different. So when you create a private load balancer, the service requires only one subnet to host both the primary and standby load balancers, and then two copies of the load balancer go into a single subnet into a single availability domain or AD. And the load balancer can be regional or AD specific depending on the scope of the host subnet. So it doesn't give you high availability in case of an AD outage, but if an AD outage occurs, a private load balancer that is created in a regional subnet within a multi-AD region is going to provide failover capability. But other than that, all capabilities are the same. So diving into one of the other services today is DNS or domain name system. And this translates human readable domain names to machine readable IP addresses. And a DNS name server stores DNS records for a zone and responds with answers to queries against this database. So when you type a domain name into a browser, the computer OS queries several DNS name servers until it finds the authoritative name server for that domain. And then that name server then responds with an IP address or other requested record data. And that answer is then relayed back to the browser and the DNS record is resolved to the web page. So kind of an overview of DNS, and you can see some of the benefits here. So you can use OCI DNS for primary, secondary internet-facing DNS. You can use it for internal workloads, keeping your information secure from the internet. And it can also request directed based on load, location, and source. There's also private DNS. So Oracle private DNS allows you to use your own private DNS domain names and fully manage the associated zones and records to provide hostname resolution for your applications running within VCNs, maybe between VCNs, in your on-prem environment, or maybe another private network. And private DNS also provides DNS resolution across networks. So, for example, another VCN within the same region, cross-region, or external network. And it can also be managed in the OCI DNS API and console. And then finally on DNS, once again, the OCI DNS service lets you create and manage your DNS zones. So you can create zones, add records to zones, and allow OCI's edge network to handle your domain's DNS queries. And then also you have your traffic management steering policies, and these are a critical component of DNS. So these policies enable you to configure policies to serve responses to DNS queries, meaning different answers or endpoints may be served for the query depending on the logic defined in your policy. And these policies can account for health of answers to provide failover capabilities, the ability to load balance traffic across multiple resources, and account for the location where the query was initiated to be able to steer that DNS traffic. And you can see you have, once again, several different options here. So geolocation, so can route traffic based on the source of your query, ASN, so route traffic based on originating ASN, and then likewise for IP prefix based on that IP prefix. And then diving into some of the different connectivity options, you have the public internet. You also have VPN Connect, which is now labeled site-to-site VPN. So this provides a site-to-site IPsec connection between your on-prem network and your VCN. And then with FastConnect, you would have more of that dedicated connection with SLA or service level agreement. So we'll be diving a little bit more into these in the next few slides. All right, so going into site-to-site VPN, once again, it gives you that site-to-site IPsec connection from your on-prem network to your VCN. And the IPsec protocol here encrypts IP traffic before the packets are transferred from the source to the destination, and also decrypts the traffic when it arrives. And going back to earlier, site-to-site VPN was previously referred to as VPN Connect and IPsec VPN, so I just want to note that change there. It also encrypts and authenticates the entire packet. So after encryption, the packet is then encapsulated to form a new IP packet that has different header information. And some advantages of site-to-site VPN are that the internal IP addresses of the participating networks and nodes are hidden from external users. Also, the entire communication between the source and destination sites are encrypted, so this would significantly lower the chances of any information theft. You also have FastConnect. So once again, this is more of the dedicated connection with the SLA or service level agreement. And one use case of the FastConnect can be dedicated access to the regional public services of OCI via FastConnect by using public peering connections. So essentially, whenever you access the public OCI services like object storage or public load balancers in your VCN, your traffic can go across a dedicated FastConnect connection instead of the internet. And the picture here just shows the co-location and Oracle provider scenarios where we have both the private and public peering connections. And then also on this slide, you can see a further breakdown of the FastConnect private and the FastConnect public. So you can kind of see the use case. So this would be more to manage your VCN resources privately, or for FastConnect public to access OCI's public service offering. You can see the bandwidth, options, protocol, all this right here. All right, so I do want to make sure that we have time for the demo. So I'm going to hop back into the console to show you the network visualizer. And if we have time, we can kind of see the load balancing service. All right, so to build off of what Brandon showed earlier in his demo, once you have your VCN created or all of your different networking components, there's something called the Network Command Center right here. If you want to be able to picture the mapping or routing, you can launch the network visualizer, and you can see as you build out a little bit more, it'll look a little bit more complex, but we just have VCN, but you can still get an idea of the options. And so right now it's just searching for different resources in our infrastructure compartment right here. You can change that. You can also include any subcompartments. And this is also just showing in our Ashburn region. So I'm going to click on this demo VCN right here, and it'll give me some details. If I want to click into that VCN, I could right here. But this is where you can access your resource maps. So if I click one of these like VCN routing map, I can get a general map right here. I can click into this subnet, and if I want to access that, I can click into that resource. I can see the gateway, the routing summary right here. And then also I can click on my private subnets, click the details here for my routing summary or my route table, as Brian covered earlier. So that's just general routing. You can also switch the map mode to security right here. And you can see for this subnet, the security list. And if I want to click into that or make any changes, this might be easy to do so here. I can click into the private subnet and see the security list for that. And then if I had a network security group right here, I could go ahead and view that. So good for as you're building out your different networking components, kind of getting a picture of how everything's connected and being routed. So this would be a very useful tool. And if you want, you can download this. So this zip file will include a high resolution map and then also a low resolution map and resource data. So you can certainly download some of those details there. All right, so that was your network visualizer. Lastly, because we only have 4 minutes left, I do want to show the load balancer service. And I didn't mention this earlier, but there's also just your regular load balancer that's good for websites, mobile apps, but you also have your network load balancer, which is better for IoT, firewalls, streaming, all of that. And you can see a further breakdown of the features between the two right here when deciding which load balancer to go with. And then if you click into load balancer right here, so I won't walk through how to create one, but I just want to point out earlier, this goes back to the public versus private load balancer. So you'd specify that right here when you're creating that. And so I already have a load balancer provision. And if I plug in this public IP address right here, you can see that it switches between my 2 backend servers, 1 and 2, every time I refresh that page. And right now it's using the round robin, so it's going to distribute that traffic sequentially. And so here's where you can see the health of your backend servers. So if one of them is down, you would see the status change right here. So if I go to one of my servers instances and I stop one of these, we'll start to see the health change for our load balancer. So right now it's okay, but you'll see in a moment that'll switch. And then every time I refresh this, we can see already it's just staying at web server 1 because I recently stopped web server 2. And then this should change in a moment. And also another thing to note too, when working with your load balancer or other different services in OCI is that you can enable some logs for those. And you can see right here, it already changed to critical. But yeah, you can see that there's error logs right here. So if one of your backend servers is down, it will end up in this error log group. So it might be a good idea to have different logs enabled for some of your different services to keep track of anything happening. So yeah, we can see critical. And then if I restarted the server, we would see that, it would change back to okay. So yeah, so you have your VCN, which is your private network that you set up in your Oracle data centers. You have different components of that, like your subnets with subdivide. Then also we have different ways of learning more. So Oracle University, Live Labs, all of that. We also do have our Day 1 and Beyond series right here, our webinar series, but we also have hands-on, cloud native, security, and did you know? So please feel free to explore those. And yeah, since we're on time, I'll pass over to Borna for any closing statements.
Thank you, Olivia. Awesome session. Thank you as well, Brandon. And I really appreciate your time and help with this session. I hope it was a good learning experience for everyone. Now it's a time for a quick poll. On a scale of 1 to 10, how likely are you to recommend this webinar to others, where 10 being the most likely? And for our next session, it will be going over the Intro to Oracle Cloud Operations on November 19th. In this session, you will be introduced to the fundamentals of operations in Oracle Cloud, and we'll explore some of the tools that we have available there. All right. And with that, thank you for joining.